Hello guys, welcome to the channel once again. So glad to have you here. So as part of our networking fundamental series, in this video we will be discussing a very necessary application layer protocol, which is DNS, the domain name system. So without wasting much time, let's dive right in. Now, to better understand and appreciate DNS, let's look at a very critical problem it solves. Anytime we tap on a link to open a website, say youtube.com, a device is obviously going to communicate with the server that hosts the website. And as you've learned from previous videos, the internet identifies devices with IP addresses. So in essence, the computer doesn't understand what youtube.com means. It is DNS that maps the domain name, which is youtube.com, to the corresponding IP address of the server hosting the site. Each row is quite symbolic to the contact app on our phones, which saves phone numbers to names so we don't have to memorize everyone's phone number in our heads. Same way without DNS could be faced with the impossible task of having to type in the IP address of every website we want to visit. DNS operates through 4 servers, which are the root server, the top-level domain server, the authoritative name server, and the recursive resolver server. To better understand the processes involved, we will be taking an example of a recursive resolution process, which is simply the whole process of a DNS query anytime we visit a website for the very first time. When we type in, say, youtube.com, first our computer checks its DNS cache, which is basically a short-term storage for recent DNS records, to see if it has a corresponding IP address of youtube.com. If it doesn't, it passes the request down to the DNS Resolver server, which is more like the errand boy of the DNS system. The resolver server, having received the request, first passes it to the root server, which is the foundational pillar of the system. As a matter of fact, there are only 13 logical root servers across the world managed by 12 different organizations. The root servers store static files, which are known as root zone files. The root zone files contain records of every top-level domain server. So when it receives the request from the resolver, it responds by giving the resolver the IP addresses of all the TLD servers of the domain which is in the request, which is in this case .com. The top-level domain is often the last part of every domain. An example is the .com, the .net, and the country-specific ones. To better understand the role of the TLD server, let's take a second to understand something here. Top-level domains are operated by organizations called the registry. They are the ultimate authority for that top-level domain. An example is a company VeriSign, which operates the .com and .net top-level domains. This registry manages the zone file of that top-level domain. The zone file here contains a list of every domain name under that top-level domain and a pointer to the authoritative name servers for each and every specific domain. Now, when web developers create websites, they purchase a domain from an organization known as a registrar, which is accredited by the registry to sell their domains. The web developer specifies which platform or authoritative name server that will hold their DNS records, and then after they will log into their registrar and enter the name of the authoritative name server they chose. And the registrar will share this record with the registry, which is in charge of that top-level domain, and then the registry will now update the zone file of its top-level domain. So now the resolver server, after being pointed to the .com TLD server by the root server, now asks the TLD server, where can I find the IP address for youtube.com? The TLD server is also not going to have the specific IP address for youtube.com. Instead, it will check its zone file, and then with the records being updated by the registry, it will now respond to the resolver server by giving it the name and the IP address of the authoritative name server of youtube.com. Finally, the resolver comes to the authoritative name server that was given to it by the TLD server and asks it for the youtube.com's IP address. The authoritative name server will now check the DNS records of youtube.com and give the resolver the IP address corresponding to the youtube.com domain. The resolver server will now update its cache and bring the IP address of youtube.com to your computer after the whole DNS query process. The computer operating system and the browser will both update their cache with the results to avoid going through the whole process every time you want to visit this particular site again. So by caching the results at various stages, the DNS query becomes very efficient and fast. So in summary, the DNS query starts from your computer, which passes the request down to the resolver server, which goes first to the root server and then gets directed to the top-level domain according to the request it brings. The top-level domain server now checks its zone file and provides a corresponding authoritative name server to that specific domain. And then finally, the authoritative name server, being the holder of the domain's DNS records, will provide the IP address of that particular domain to the resolver server, which brings the results back to the computer. This whole process is actually completed within milliseconds in real time. So that is an overview of the domain name system DNS. If you learned something from this video, like, share and subscribe to the channel for more content on the networking fundamental series. Also, you can leave your thoughts and comments in the comment section below. Until next time, goodbye and thanks for watching.